This is the Aftermarket Radio Network.
Welcome, everyone, to yet another episode of Diagnosing the Aftermarket A to Z. I'm Matt Fonslow, and today I'm going to be joined by Haakan Light, and we're going to be doing a kind of a Q&A. I just really want to thank everyone for the feedback that you've been sending me and requests for topics. And by far, the number one request is to discuss scopes, oscilloscopes, digital storage oscilloscopes, lab scopes, whatever we want to call them. And I've invited Haakan on to basically, we're going to try to do a Q&A, and he'll be asking some questions, and I will try to answer them as best I can. And hopefully we can clear up any kind of questions that we've seen coming in for an episode like this, or any questions that you may come up with later on. So thank you very, very much, Haakan, for joining me tonight.
Glad to be back.
Yeah, and while we're in the thanking mood, I would really like to thank our sponsor, NAPA. How does NAPA support your auto care center through national marketing? NAPA will build upon the already successful Know-How for All campaign and promote auto care offerings and services to our do-it-for-me customer with support through sales driver promotions, optimize targeted media in local markets and improving channels, give your repair facility an online presence on NAPA Online, generating millions of views per month. If you are interested in partnering with NAPA Auto Care and capitalizing on the NAPA Know-How for All national marketing campaign, contact your servicing NAPA Auto Parts store. All right, Haakan, thank you very much again for joining me. How is everything over at Top Done?
Busy. A lot of stuff going on. Going to ASTE to spend some time promoting the products this week, and then BIMMERS the following week, which I believe you are also going to be at. So that'll be pretty cool. I'll actually be not working in a Top Done branded booth either of those two shows. I will be actually in the AES Wave booth for both of those shows, just working to help promote the product locally within their booth. And also I'll probably help customers with other stuff related to AES Wave products as well. So
very cool. Yeah. ASTE might be wet and windy.
Yeah. The hurricane is supposed to hit that, I think, basically Friday, I want to say. So I fly in before it hits, but the remainder of whatever's left of the hurricane is supposed to hit there on Friday. So hopefully it doesn't come sooner and then make my flight not land like it's supposed to. So
they'll be able to land it with the engines off.
Yeah, right.
We're getting plenty of lift with just the wind.
Gliding in, yes. Yeah, that's the only part about I worry about. But it should be great. I can't even describe how many people I've seen respond and say that they're going to ASTE. So I wanted to go last year and I missed it, but there was a lot of response from a lot of people talking about being there and whatnot. So I think there's a ton of people I'm looking forward to meet in person who I've known through Facebook and other various forums and whatnot, which is kind of one of the greatest things about shows is you get to meet people that you've interacted with quite a bit that you've never actually met them in person. And it's it's a different experience to meet people in person. And you always find that there's additional positive element that you get from the in-person interaction that you don't from just talking over Facebook Messenger or phone or whatever else, whatever other context, as you can imagine. So I guess the first thing to ask about is, let's define what a scope is. Tell us how you would describe a scope, how it functions, what it does for you as a general statement.
I guess how it works, although maybe not technically accurate, but I think plenty good enough for the vast majority, not of just people, but for what we care about, is it's a very, very, very fast voltmeter that plots that voltage over time on a graph. So it's a graphing voltmeter, extremely fast. That's probably the easiest way and maybe more technically sound than I'm giving it credit for, but fundamentally that's what we're going to call it. The important part is it plots voltage over time. And, I'm saying that voltage, the vast, vast majority of them do. There's a few power graphing meters or graphing multimeters that may graph more than just voltage over time. I suppose we could debate whether those are truly oscilloscopes or not, but for the most part, we're graphing voltage over time, and then we can take advantage of that with different transducers. Anything that measures a phenomenon that's not voltage and turns it into voltage is a transducer. So like a microphone, we know about pressure transducers, current clamps, those are all transducers. So essentially we're plotting voltage over time. And because of that, we can see characteristics that are very, very difficult, if not impossible to see digitally with scrolling numbers, changing numbers. So take a voltmeter and we go across the battery. We can watch it say 2.5, 2.6, 2.7, whatever volts, assuming a good battery, I guess. We can watch it stay that way. And I suppose we could take a stopwatch or watch the clock or our phones or something and determine that it stays at that voltage for 10 seconds or 5 minutes or whatever we want. Or we could hook up the oscilloscope. Specifically, for most of us, that's going to be a digital storage oscilloscope or a DSO. And we could set however much time on a screen, 5 minutes, walk away, come back and look at the screen and say, okay, it maintained that voltage for 5 minutes. And then if there is changing voltages, pick a signal on a car, we can see that. It's much easier for us to interpret. Human brains are really not that good at dealing with quantitative data. We're not. Just go outside of auto repair or the car repair itself. Anybody that deals with metrics over time typically is not looking at a spreadsheet. I mean, they could.
People like graphs.
Yes, they're looking at graphs and they're looking at characteristics. They're looking at trends. Well, that's what we're doing with voltage. We're looking at trends. We're looking at characteristics. And I think human brains are wired, even like instinctively, to recognize patterns. Patterns, be they pictures or patterns of behavior, patterns of events. That's what we recognize. And specifically the symbols, an oscilloscope signature, a voltage trace of some sort generates a signature, generates a symbol that easier for us to interpret and memorize. Most of the time, if we were to put up a voltage trace off of the control side of an electric solenoid, most technicians that have any kind of experience with an oscilloscope, working in the shop or going to classes or reading books or watching videos, are going to be able to say that is an electric solenoid. They may not phrase it that way. They may say that's a fuel injector, that's a shift solenoid, that's a evap system purge valve, something of that nature. They're all electric solenoids. They memorize that. So that's where a scope becomes extremely powerful, namely when we're getting down to maybe component level testing, circuit level testing. I think a lot of us, if the first grab in a diagnostic process is a scope, depending on the situation we're talking about, right? So, but as a general statement, I think it's safe to say that if the first thing you're grabbing in your diagnostic process is an oscilloscope, you may want to revise your process.
Given the case, yeah, certain cases maybe, but a lot of cases probably not.
There's specific tests that maybe we'll bring up later that are fine to go to early on because they're telling you more about a system than they are about a specific component. But if we're busting out the scope with maybe weak intent, then we need to step back and use other tools, probably a scan tool, to give us a reason to use the scope and where to point that scope's capabilities. We have a reason for doing this. Why am I going to use my oscilloscope on this circuit? Okay, because I have codes, I have certain behaviors, and looking at scan data that leads me towards these components, and now I need to drill down and say, is this component or circuit good, or doing what it's supposed to? And that's where the scope comes in, and it's hard to rival it. Don't get me wrong. Don't kid yourself. I love using headlights or various size lights to test circuits. And if I don't have use a scope, I generally don't. But because of what we do, I do use a scope. I would say at least daily at some point it's getting used. And some days it seems like every car. Another aspect to think about, to consider, I think with an oscilloscope is kind of like on-the-job training. That the more I learn about electricity, electronics, the more I use a scope, the more training I receive about just in general auto repair, but specifically diagnostics, electrical, electronics, stuff like that. the scope becomes a teaching tool. It's showing me what's going on, especially if I have a known good system, known good car. Now I kind of know what it's doing, and then I can go research why, but I can see what's going on.
Yeah, it can be educational to just scope known good cars. You learn things and gain a deeper understanding of a system by doing it. I agree, totally. I mean, I'll be honest, I learned a lot from a diagnostic perspective before ever using a scope. And then when I started using a scope and then learning more of the different testing techniques, a lot more stuff started to click and the pieces fit together a lot more cohesively. As I started to understand more and more of what was happening on the scope, I was able to put that together with the other knowledge I had and form a better picture of how everything fit together. So I totally agree.
Yeah, an example I would have is many years ago, I worked for the largest distributor of Pico in, I think, North America. I think this was after that, but I went to a car manufacturer to show them about Pico. And they were thinking about bringing Pico in as an essential tool. And it turns out they didn't really invite, and I don't want to say me specifically, but invited a representative from Pico, if you will, or I should say maybe more technically, a representative of Pico. They had a question about fuel injectors, specifically gasoline direct injectors. And the training material they had did not match what they were seeing on the scope. And they thought, please don't get me wrong, some of you are going to probably snort and laugh when I say this, but they were concerned that the reason that the pattern did not match their training material was because the Pico scope did not have enough sample rate. For one, it wasn't a sample rate issue. The signal wasn't that fast. It didn't matter. It wasn't a speed issue. The issue was the training material is wrong. What they were looking at, they thought, was scope noise, was kind of the hold section, pulse width, hold section of essentially a peak hold injector. And we could really rewind the clock. And I think Nissan was doing that on fuel injectors, regular TBI injectors, peak hold, and they would pulse width modulate the hold section and then reduce current flow, all that you didn't have to saturate it to hold it open. You just didn't need that much current flow.
Easier on the drivers, I assume?
Yeah, it's a strategy. And if you don't know, then you don't know what you don't know. And unfortunately, the car manufacturer, right? Like they're providing you this material and it's wrong.
You're at their mercy.
Right. And I'm sure it's not a normal reaction to start questioning the manufacturer. In our world, the independent world, we do it all the time.
Yeah, we do it a lot more, I would say.
Yeah, all the time. But in their world, the vast majority of the material they have, even if it ends up inaccurate, is enough to fix the car. So anyways, that's what it ended up being. And what I mean, where I'm going with that is now it's a teaching tool. This does not match what I'm being told is good, known good. Now I can try to research why. They lucked out, I knew. Maybe somebody else that would have went in there would know as well. Maybe they wouldn't. And then how do you track down what's going on? So in our world, I think that's a good thing, is especially when we have known good, it gives us a reason when we're seeing something we would not expect to go, what's going on? And now trying to find avenues to learn. What are those avenues? Is there a training instructor, classes, material or videos, or some sort of way to find out like what is going on? Forums, professional forums, we have many. Diagnostic network, so many Facebook groups and pages of really, really high level individuals that if they don't know, they might know how to find out. And then everybody benefits. If
they don't know, they probably know someone else who does. That's what I count on, right? I might know, but if I don't, I bet I know someone who does.
Knowing a guy who knows a guy, that is a big deal.
Helps a lot. Whole lot.
That's the lesson.
Yeah, right. Yeah, it does make a tremendous difference. Yeah, right. Take that away. That's all you need to know. Yeah, I know that it does make a tremendous difference, though, the networking aspect. For me, just the experience of learning scopes, I bought a book that was by an author named Graham Stokes, and it was just like a Automotive Oscilloscopes book. And it was just basically a bunch of waveforms of here's what these types of components look like generally. It wasn't meant to be here's a known good on this vehicle, here's a known good on this vehicle. It was just meant to get you comfortable with waveforms. And from that book, I spent more and more time just connecting to vehicles and just literally screwing around with the scope until I could get a waveform that approximated what I thought it was supposed to look like on the screen. And that's literally how I learned scopes. That was all there was to it. Like, we're kind of spoiled now because we got some scopes that'll literally, you plug it in, you connect it, it basically sets itself up, and you're like, I don't need to know anything. I just need to be able to plug it in and connect it to the right spot, and we're done here, right? I mean, it's kind of cheating in some ways.
Yeah, when I went to my 2-year, we had Sun machines, and one of them was MCA, and that had regular lab scope functions that nobody really knew about. I found it on accident. I was screwing around. But we would look at ignition waveforms, secondary ignition, that was like part of our testing, not testing of the car, of course, but in class, we had to do these reports. So we were using scopes that way. Just, we would have probably said an ignition scope. My second year, there was a car, GM, was setting mass airflow sensor codes. So my college instructor went down. So in the technical college, they also had a band instrument repair program. And they had I'm pretty sure it was a Tektronix analog lab scope, kind of a big benchtop, 2 channels, I'm pretty sure, if I remember right. I scoped the mass airflow sensor and I saw the square wave and had really no idea what I was looking at. I saw a square wave and I knew when I revved the engine, the square wave pulse train would get tighter and tighter, closer together. And long story short, we put a mass airflow sensor in it because we didn't know what else to do and fix it. Looked like geniuses. I'm probably 17 at the time, 18. And then I went to a 3rd year, and that's where we hit scopes really hard. That was a major part of the program, was using a lot of different scopes, mainly a Fluke 97, which, if you go Google that, they called it the grand piano because there's so many buttons on it.
It did have a lot of buttons on it, that's for sure.
And it was not the 98. The instructors refused to get 98s that had a nicer screen, fewer buttons, too much hand holding. And then we had a Sun LS2000. We had the OTC version of the Intero PDA 100. And then there's it was a rebadged Tektronix. I think it was called like a Cal, or pretty sure it was called Cal, K-A-L. It was fairly popular. The Mac tool trucks had them. They would sell them on there. And I think they might have been Mac badged, maybe, but they were rebadged Tektronix. Yeah, I think those were the main heavy hitters we had. But, we had to scope a whole bunch of stuff. So you start picking stuff up. And then really, I would say the big time learning, my second job, where they hired me because I liked to do drivability. I liked electrical. I would never imply I was good at it, but I liked it.
If we're talking about scopes as a general statement, we can see that we talked a little bit about what it is that a scope actually is. What do you see as the utility of a scope? What can it do for you that other testing methods maybe can't? Where does it add something to your picture from a diagnostic perspective, your understanding of the car, things of that nature? Where do you see the value in it, and what place does it have in your toolbox, so to speak?
Offhand, I think it's flexibility, because you start adding transducers, current probes, current clamps, pressure transducers, accelerometers, stuff like that, piezo devices. You can start looking at more and more phenomena on a vehicle than just voltage of signals. Now I can hook up my current probe and, a low amp current probe, and I can watch the current flow, whatever device. I don't think we have to get super specific, but there's characteristics of some signals, usually actuators, that there's characteristics in watching current that differs from voltage. You just really won't see it, or you won't see it easily. And that makes it a pretty powerful technique. And then, of course, pressure, looking at pressure. I think right now, we get a lot of fanfare for in-cylinder compression or exhaust pulses, maybe even intake. Those can be some very, very powerful tests that can save you a terrific amount of time. But also fuel pressure, evap. Use a good pressure transducer to watch evaporator or fuel tank pressure, to even if only to test the fuel tank pressure sensor. Now you have something to try to test that and its accuracy. It doesn't happen often, but I've run into it where I have skewed FTPs, fuel tank pressure sensors, and I find it with a pressure transducer. Those are just a few of the things. And in accelerometers, we're looking at vibration. And, maybe we can couple that with other software, but you could also hook it up to a scope. And depending on what we're chasing, point us in a direction, if not to the cause. It brings up another supportive reason that the scope has a good purpose in your process, in your toolbox, is comparison. It allows us to compare, and not so much like good versus bad, but it also lets us sync to certain things, to time align to another event. Maybe the number one thing we time align to is number one cylinder firing, or TDC, or close to TDC of a cylinder spark plug being fired. That's probably the number one thing. But there's so many other things we can do that we can correlate to. Those are probably the two big things, is flexibility and then the ability to relate or correlate to other events. It seems like we're maybe not doing this in a very chronological way, but I think I've said channels once already. We're talking about correlating. That has to do with channels. When somebody's talking about channels of a lab scope, they're basically talking about the number of signals it can look at one time. One channel scope, you can only look at one signal. You can only have it plugged to one circuit and see it on the screen. That's it. A 2-channel scope, you can look at 2 things. 4 channels, of course, 4, and then really 8. Those are the main ones we have out there. It seems like there's one out there that's technically 6 channels.
Yeah, I feel like there is one. I can't think of the name right off the bat.
I think it's USB Autoscope technically might have a 6-channel version. I could be wrong, but those are the heavy hitters. There's usually 1, 2, 4, and 8. And 8 really is only come into prominence the last, I guess we could go back a ways. Wow, 15 years ago, there was an 8-channel out, but now we're seeing some more coming out. So there's a little more competition in the 8-channel realm. 8 channels is a very busy screen. That's what I will say about that.
You might need multiple monitors to process that visually, right?
Yeah, it's a lot. For a day-to-day in the bays, you'll probably use 5 more than you will 8. You look at 5 things far more than you will 8.
4 cams and a crank, perhaps.
Yeah, from an education standpoint, 8 channels can be pretty powerful.
You could see an awful lot of things happening in the process of what an ECU is actually doing if you had it rigged up to 8 separate channels. You could even be looking at inputs and outputs of a given subsystem of the ECM, which could be pretty cool.
Yeah, and maybe that's part of the answer about where does it have its place. So subset 3 would be cause and effect. That might be correlation, a twist on that word, but really a scope can show you cause and effect.
That makes sense. I would agree. I think that's a good description. Going into the channels and whatnot and discussing some of the physical features of the scopes and whatnot, maybe you want to talk a little bit more about, so what are some of the considerations of a scope with respect to, a scope has this many channels. How does using more than one channel affect the performance of the scope? Do all scopes remain the same when you hook up multiple channels, or do we see a change in performance as you add more channels to the equation? I think that'd be something you could maybe explain a little bit, because I know some people don't understand or have a grasp on that for sure.
What happens is we have to start talking about the scope itself, how it works. And again, I'm going to really smooth over some stuff. If somebody really wanted to go after me about the real technical way it's operating, they could probably crucify me pretty good. If we can just get the gist of it.
We're just trying to be practical here, right? Not razor sharp precision.
I don't think it benefits anyone to know. I don't think. Maybe. But ultimately, we're talking about, and I said it earlier, digital storage oscilloscope. So many, many years ago, the ignition scopes and lab scopes, kind of like I referred to when I was in my 2-year scope in that mass airflow sensor, we had analog scopes. Essentially like a beam would be drawn on a phosphorus screen, a CRT, and that would illuminate a trace. And they kind of had a green or a blue tinge to them or whatever. And that As the signal came in, that drew the signal. It was basically in, blasted out right away. There's very little delay, and they were limited by how fast that component could move shooting that beam. And then we get into what we're vast majority of us are using is the DSO, the digital storage oscilloscope. And now we have some processing involved. So we sample a signal, we measure it, and because we store it, it goes into memory. So that brings up two, almost immediately, really three specifications of a scope, a digital storage oscilloscope. Three main specifications. One is the sample rate. How many times can the scope measure this signal? So how many times can it look at this signal and plot it in memory? That's number one. Most automotive scopes are kind of in that 1 million samples per second range. So it can look at it 1 million times a second. Have more and more coming out that are much, much faster.
And that would be the big chief difference between that and something like a graphing multimeter is the samples per second, correct?
Much different. More and more of the scopes are starting to crawl up into the 10 million times a second. We've got a few out there that are 400 million times a second. I think we're going to start seeing them break into the 500 meg, if not 1 gig a sample a second. That's more into what we would say maybe general purpose type scopes, but that's the realm where we're heading. It's like everything. It's going to get, as the components to build the faster scopes becomes more affordable, that's what they're going to do. They're going to get faster and faster and faster. Okay, so I said we're going to sample a signal and we're going to store it. We got to have somewhere to store it. And then we're talking about scope memory. It's often referred to as either scope memory, record point length, memory buffer, sample point memory buffer, something like that. Those are the names associated with memory. It's one aspect of memory. This is a dangerous way to explain it just because it's so visual. We have to disconnect in our brains the display from the scope memory. Just don't correlate them. We're strictly talking about the memory. And one way to think about memory is like a pegboard. And the memory spec, the record point length or the memory buffer size is the holes of this pegboard going left to right. Those specs vary. Every scope's going to be different. I think the snap-ons were always in that 512,000 range. Some of the Picos are getting, they were 32 meg, and now I think we're 250 meg or 200 meg, meaning there's 250 million of those holes in that pegboard going left to right. So this is the memory. That's how it's going to measure it, and it's going to plot it in memory. But that's the time component, right? It's measuring it in time. Each one of those holes we're talking about in this sample point memory buffer is associated with a time frame, almost like a time stamp. But there's another aspect of this pegboard, right? We don't have just this single line of holes going left to right. We now have the rest of the pegboard going up and down, and that is our vertical resolution. And, they got to be jerks about it. They don't just tell us a number. It's not like when we go buy a television and high definition television, they give the specs as, it's a 1080, 720,
8K, 4K.
We get into 4K and 8K. Now they kind of did it to us again because it's a 1080 television has 1080 points, if you will. We'll just say they're LEDs just for this discussion. 1080 LEDs going from the bottom of the screen to the top of the screen. So if you think about that, the highest resolution TV that's a 1080 would be the smallest screen you could get with 1080 points in it. It wouldn't be the biggest TV you could get because those points get further apart. I guess television buyer advice. 4K kind of goes out of the window. Now the screen's kind of divided up into 4 segments, and now you have, they divide it up and it's not exactly what we think it is, but that's beside the point. Scope specs, what kind of sucks for us is that the vertical resolution is given in bits. You have 8-bit, you have 12-bit, 16-bit. And there's probably more. I think I've seen somewhere around 14, but automotive generally it lives in 8, 12, and then 16. The 8-bit part, 12-bit part is really 2 to the 8th. So if we do the math, 2 to the 8th is really, it's 256. 2 to the 8th power. If we go to 12-bit, it jumps up to 4096. That's a huge, huge change.
Big jump.
Basically what that's saying when we're talking about that 256, 4096, what that's saying is that's the number of holes in that pegboard going from the bottom of the memory to the top of the memory. So you could see now how those points on a 12-bit scope are going to be much, much closer together than the 256. And that's not to just bash 8-bit scopes, because early on, 8-bit is what you had. There's so many scopes you can buy very, very economically that are 8-bit. Pico had 8-bit scopes. I think technically still does.
Yeah, I think there's a few still out there.
Where you start seeing issues is when we're zooming in. Where that really rears its, ugly head, if you will, is you start zooming in on an 8-bit trace and you start getting this almost, when the voltage is rising or falling, it kind of gets a stair step look to it, because the scope's going to measure a voltage. It can only put the pin or that memory point, sample point, in a spot.
It's like connecting the dots. If you have more dots, you have a smoother line.
Correct. And let's just very, very exaggerated example. If the points, one point vertically is 1 volt and the next hole up is 2 volts, and you measure it at 1.5 volts, there is no place to put it at 1.5 volts. There's nowhere to put that memory point. It can't go anywhere except 2 volts, assuming they're rounding up, which I think they would. That's how that would work. If it was 1.4, it rounded down. It's less accurate. Not that in the vast majority of things that we deal with care that tightly.
No, usually not.
Yeah, especially in the ranges we're talking about. But what happens is you start zooming in on these things. If you've collected a lot of time or squashed it down and you're trying to zoom in for some detail, it's hard to pick up the details. One example may be like, again, we'll go back to the fuel injector voltage trace. You're trying to zoom in after a capture where you've caught a little bit of time, you zoom in and that pintle bump becomes very difficult to see.
Right. You can't see it.
Right. Because you have the stair step going on. Are you a repair shop owner? Do you find yourself struggling with any of the following? Uncertainty about the future and competition. Are you spending too much time managing chaos and struggling with new employees? Do you lack time to invest in learning best practices? Or there's no time to spend on effective marketing? How do your finances look? Are you reactive rather than proactive? Do you know where you should be, when to grow, when to shrink? If any of those situations describe where you are today, you are finally in the right place. Repair Shop of Tomorrow is NAPA Auto Care's newest endorsed partner. They are helping shops all over the nation run more profitable automotive repair shops by utilizing proven business best practice marketing and coaching to leverage NAPA programs to drive quality, car count, sales, and profits. Repair Shop of Tomorrow will look at productivity, efficiencies, effective labor rate, average hours per car, labor profit percentage, measure and manage labor, and how you can create net profit. Team up with coaches to create systems, operations, and procedures using a business flow chart to help you reach your goals. Repair Shop of Tomorrow will help measure and manage the results to help each business succeed. Best of all, it's not do it yourself. It's all done for you. Their goal is to help dealers do what they do best, fix cars and build relationships at the counter and in the community. Repair Shop of Tomorrow will take the other minutia off your plate. The Repair Shop of Tomorrow offers a tier-based program to not only generate more business today, but to transform your shop into a top-level shop of tomorrow. Repair Shop of Tomorrow can teach you how to make your shop profitable. They can teach you how to recruit and how to make more labor dollars for your shop. Interested in Repair Shop of Tomorrow? Call 440-545-1230 for a free 20-minute, no-obligation consultation, or contact your servicing NAPA Auto Parts store. Really, those are the 3 heavy hitter scope specs to look for. And I would love to say, more is better, and maybe that as long as they're all better, because we're going to get into some weird dynamics You can have a ton of sample rate, but if you have a very short sample point memory buffer, so what? It can't plot anything. It can't go anywhere. It samples at 500 million times a second, but the memory is 1 million samples. So if you have 1 second on the screen, your scope can sample at 500 million times, but there's only 1 million holes to go through. So what does it do? It starts rejecting. And that's where it starts dividing the sample rate in half, if you will. It's not, I don't think it's really actually slowing the processor down. It just ignores it.
It'd be like the same thing as watching a 4K movie on a 1080p TV. Would that be a good analogy? You can't really see it.
Yeah, it's just going to reject it. It's going to, quote unquote, slow down so that sample rate is as close to or lower than 1 million as it can get. And that might act like it's slowing way down. It just keeps rejecting those sample points. And that's one trick that manufacturers use, and I don't mean car manufacturers, scope manufacturers use to get around that, is something called peak detect or min-max, where it keeps track of the highest measured point and the lowest measured point in that frame between where it can plot the points. While it's rejecting all these, it's keeping track and the highest and the lowest. And then it will plot both. So that's why a lot of times if your scope has a peak detect mode, when you turn that on, you get this really thick line. It's not because it's sampling so much. It's because it's plotting 2 points and connecting those vertically, which can't happen, right? Those 2 points didn't happen simultaneously. That is impossible. But that's why you get this really thick line. And they're covering up, if you will, for a lack of sample rate. Sometimes it's less to do with the actual sample rate itself, but a lack of memory. There's just no points to store this in. So it has to reject all these. That's an important thing to know. You have to take these specs and they all work together to provide you with the ability to accurately reproduce a measured scope trace or waveform.
Well, you've talked about it before, just knowing the limitations of your tools, right? I mean, that's important to every technician, regardless of what we're talking about, whether it's scopes or, whatever it might be. It's important to know the limitations of any tool you use so that you know whether or not you can trust the data or whether or not what you're getting is meaningful, right?
Yeah. I guess the story is that you can look at these scopes online and marvel at the sample rate, but you better pay close attention to the memory, because you can have a screaming fast scope, but if there's no memory, it's going to be difficult to use it in the time ranges that we typically look at signals. Because in the grand scheme of things, automotive signals are slow.
Other than like flex ray, right?
Well, I was going to say flex ray, but honestly, I don't know how much analysis we're really doing. Even we're not, or at least I'm not sitting there picking apart the waveform. I'm looking at the physical layer. Am I hitting my 1.5, 2.5, 2.5, 3.5? And maybe kind of looking for a certain look to it. Maybe I'm missing out, but I don't really pick it apart. So that's kind of the thing, is to keep in mind that these things all work together. You could have a scope with a slower sample rate, but a lot of memory, and that might be more functional for your daily use than something with a terrific amount of sample rate, yet not a whole lot of memory. It's just something to keep in mind. What happens with those super fast sample rate scopes with no memory is you have to look at the waveforms at very fast time basis. So you can't really squash a lot of data on the screen and zoom in or whatever for details.
I found that sometimes you can do some of them have screen record or video screen recording, so you can screen record it. So then, you fit what you can on the screen. And if you take a video, I did that with a scope I had a while back that was a 4-channel that suffered from that exact issue. It had very limited overall memory storage depth, so you couldn't get a lot of waveforms with any kind of resolution or clarity. So instead, I would put it at a time base where I could see a decent enough amount on the screen, and then I would screen record, and then I could go back and watch the video, and the resolution of the video was good enough I could catch the glitches that way. So yet another way I had to compensate for a deficiency in the scope's function, which still sucked, but it worked, but it wasn't ideal, of course. So we've talked about, what is a scope? What are some of the basic terms and things that you're considering? What a scope can do for you, what it is, and its overall how it can contribute to your diagnostic process. So what are some of the scopes out there that, that you've been exposed to, and like, what have you seen for things? Obviously, everyone knows your background. You've used Pico quite a bit, but what other scopes have you come across? What are you familiar with? What have you seen in terms of features? Have you heard anything good about any ones? Heard anything, interesting out there? New technology in the realm? Anything that you would say that you've come across that would be good to share?
Well, I think one way I may twist that question, it's one of those situations where I think, not maybe to the degree of scan tools, but it's one of those things where you may find yourself wanting, if not needing, multiple scopes. And what I mean by that is you might have the heavy hitter, whatever that one is, and everybody's going to argue about which scope that is, and they can have it. Go argue about it. I don't, whatever. I know which one I have. Those are the ones that when I need multiple channels and I want to look at stuff a certain way, that's what I'm going to. But a lot of stuff, I grab the U-scope, the AES Wave U-scope. It's a single channel. So yeah, I'm not comparing anything. But, it's small. It's a 12-bit scope. It's got really good resolution. And it's fast enough to do the stuff I usually need it to do. And, a lot of times we don't need to look at multiple things. And I don't mean that to dog on anyone or anything. It's just, if I'm going to look at some HVAC stuff and I'm under the dash, maybe don't want a PC-based scope. I don't care who makes it. The U-scope is going to do what I need it to do.
Well, setup speed. So that's a consideration, right? Because depending on what test you're going to do and, what the application is, maybe you want to have two scopes. Maybe you want one that's really, really quick grab that you can just go, boom, get exactly what you need if you only got to look at one thing. And then maybe you have a heavier duty scope with more powerful specifications and capabilities for greater depth of information collection, right? So that makes sense.
Yeah, either greater depth or cast a wider net. Yeah, I think that might be like a Brandon Steckler kind of a patented type of term, casting a wider net. But there's times where sometimes you need to cast a wider net. But also, yeah, I'm going to be looking at faster signals or just maybe multiple signals. And now the PC based is nice because the screens are usually so big, or I can project them to much bigger screens.
40-inch screen on my Diag cart? Yes, please, right?
Yeah, that's nice.
Who doesn't like that?
Yeah. The other thing is the best choice is the one you're going to use, because it really doesn't matter. You could have the quote unquote best scope ever built, whatever that is. And if you don't use it, who cares?
Right. It's like having a hot rod. If you never drive it, why have it, right?
And if you've got a scope that doesn't outright lie to you with, aliasing that you use all the time and have great success with, who cares what everyone else says? Number one, get one that you're going to use. And you may find that you always wanted the one and you don't use it because time investment in setting it up versus the something quick to grab. And then you may find you've got that quick to grab scope and it's great however many times, 80% of the time, 90% of the time, that 10% or whatever that number is, whatever BS number I can generate off what that would be. When you need it, you need it. So you find yourself at least, you probably have a couple.
Well, I'll be honest. I had two, and one was a handheld that was a super quick to set up, and I found that I did use that a lot for really quick stuff, and I sold that one. Well, and then I had only a PC-based one that took a lot more time to set up, and I found that I didn't want to use it as often just because it was more of a pain in the butt to set up. But I found that there were times where I got lazy and didn't scope something I should have because of the setup time, and it burned me. And then now I have two again, and one of them is faster to set up than the other one. But again, I have two for that very reason. It is something where once you start to see the reasoning for having each one and you get the rationale for having more than one and, what each of them can do for you, boy, yeah, you do start to go, man, I think I do want to have two, right?
Yeah. And then I think to get to I don't know. I'm worried sound like I'm avoiding it. But with the other scopes, other things, I would say years ago, I probably had used a far greater percentage of what was available than the percentage I've used recently.
Well, there's a lot more of them out there. Yeah.
Yeah. I think, and you see more people using different ones that you may have never heard of and they like. As for like features, I think a lot of the features, they're getting better with just the user interfaces. I find that's what separates a lot of the scopes I use, whether I like them or not, has more to do with the user interface than it does the actual scope performance. Gets back to like this scope could be super powerful hardware wise, but the user interface is so brutal. I'll use the weaker scope just because the user interface it's just easier to navigate. I can get where I need to go faster. It makes more sense, maybe not to pick on any one manufacturer of scopes, but I think Snap-on, depending on where you started using that Snap-on scope, you would find it either super intuitive and then difficult to go to Pico or Pico-esque type of interfaces, mainly talking about zooming in versus zooming out.
Sure, yeah, that's a huge difference.
Yeah, Snap-on, the screen, you're looking at a small window into the much larger buffer. That's the way to think about it. So most of the time you have a buffer bar filling up that you can see, like it's going across left to right, and it's a bar that's filling up. And then when it gets all the way full, then you might see some sort of a icon of some sort, maybe just even a bar or a line going across as it empties and refills, right? So it's one of those things where it empties out the end and refills on the input, if you will. If you learned that way, it's a seamless buffer. As long as you don't lose it off the end, if something happened, whether you saw it on your screen or not, you hit the pause button, you have it. You can scroll through it. If you grew up using that is powerful. That is why you use a Snap-on scope. It's got a seamless buffer. You don't have to worry about it. You go to how most other scopes work, that the screen kind of represents the memory buffer. Now, I'm not saying like point for point, because usually the resolution of the screens is much less than the resolution of the memory. But when that screen fills up, the buffer is essentially filled up. And if that screen goes away, it's gone. You've lost it. You can't get it back. You needed to pause before that screen finished. And then we have other ones that do segmented memory where, depending on your choices of time base and how many sample points you're trying to collect, that screen may now again represent a small segment of memory. And there may be a gap, if you will, between screens because of the way things work. That can be counterintuitive if you grew up using the Snap-on way, but vice versa if you grew up using we'll just say more of like a Pico way, or, honestly, even like a Tektronix type. Snap-on becomes wildly unintuitive.
That's where I'm coming from.
You know what I mean? Like,
oh yeah, for me, I pick up a Snap-on scope and I don't have any clue what the hell is going on. But I learned with a Pico style interface.
Forget about the hardware. The hardware could be phenomenal, but if it doesn't make sense how it works, or you find that user interface difficult,
yeah, it's meaningless.
So, and then we're seeing a lot of the automotive scopes coming out with, let's just say software. I'm just going to say software or programs, either separate or integrated with the scope itself to allow for further testing. That's not what you would immediately equate with an oscilloscope. So NVH is kind of one that pops to mind. We have at least two off the cuff that I can think of, scope manufacturers that have software for NVH, and they are plotting, voltages, if you will, over time. But then they're relating it to other things, maybe caught through a DLC or input in some other fashion. I think they call them like CAN decoders, but really it's like communication decoders, if you will, or serial data type decoders that are gaining popularity. Those are the big things that come to mind. Yeah, just different ways that they come up with processing data and displaying it to you. Almost like scan data. Some scan tool manufacturers would show you data, of course, numerically, digitally, and then maybe they'd let you graph, which graphing's great. And then some of them would display them in like gauges. You could put up gauges and all that, which always seemed very silly to me, but maybe somebody else, that was the way. Like once they had the gauges, like, oh, that data took on a whole new meaning and it worked. I don't know. I don't even mean it judgy. They're getting creative with how they're displaying data to us. I hope that didn't seem like I was skirting anything. I'm just trying to level.
No, I don't think so. The reality is that what it is that makes a scope good at a specific task is just reality. Like, it's not a judgment. It's not a condemnation. It's nothing. It's the same thing we said, right? You have to have an understanding of what the limitation of a tool is if you're going to be successful in using it. Because if you don't understand the limitations, you can get yourself into a whole lot of trouble. You can make errors in judgment. You can screw things up. You can miss things because you don't even realize that your tool is missing things, right? If you don't understand, you will miss things, and then the tool isn't going to do anything for you. You're flying blind.
Yeah, there's a couple of instances there. One, let's pick on Snap-on first. If you didn't understand what it was doing, how that was accumulating or capturing data, storing it, and displaying it, if that didn't make sense to you or nobody really pulled you aside and explained it, what would happen is you would slow your time base down to squash more data on your screen. Now, remember what I said about Snap-on. That screen is a small window into the entire buffer, all that memory. You're just a little window. So you start squashing that down. Remember, when we're talking about sample rate and memory, we're starting to sample more than we have room. So we have to start rejecting. So what happens is, you're told it's a lack of sample rate. I suppose technically it is, but ultimately it's just poor scope habit specific to that scope. And what happens is you've basically put the scope in a situation where it can no longer accurately recreate the signal. A fancy term for that is scope aliasing. Aliasing is a failure to accurately reconstruct the waveform or the signal being tested. Yeah, it's really just not providing you an accurate representation. And you'd have a misdiagnosis based off that. A high data rate crank sensor, they're looking for a dropout, so they're slowing it down on their screen so they could see this dropout. Well, essentially they would create a quote unquote dropout. The signal's not dropping out at all. The scope is showing dropouts because it can't reconstruct the waveform. So these parts are getting replaced on a car incorrectly, or not, the part itself wasn't installed incorrectly, but the diagnosis was incorrect. You kind of had a similar issue with Pico, depending on which version of software we want to talk about, right? There was Pico 5, long gone, Pico 6, and even Pico 7. You can request how many sample points the Pico will try to capture, but the default settings are, for the most part, relatively low. So you have this scope capable of capturing and storing, 200 plus million samples, but the default setting is 100,000. And now you're looking at a very fast signal and you have a lot of time on your screen. So it's trying to collect a lot of samples so that if you zoom in, it has this detail, but it's only collecting 100,000 of them. That's not that many samples with a fast signal and a lot of time. So now you're looking at it and you've basically aliased the scope. It looks terrible. And you're like, wait, I thought this thing was supposed to be so freaking good. Why doesn't mine look the same as so-and-so is online? And again, if you don't understand that that's something you can change or adjust, who cares what the hardware can do? Understanding your scope, there's always just levels of understanding. Like, really the best first thing is to be able to get a signal on the screen, accurate signal on the screen. And then maybe there's some certain features worth learning, triggering and maybe some measurements, stuff like that. And maybe graphing other, not so much, I don't want to say phenomenon, but frequency, right? You can graph the frequency. That's important. Or pulse width or duty cycle. And then all of a sudden you have these really, really powerful features that you probably use once in a great while, but you should know about them. And I don't know if every scope has that, but I would say, when you're talking Pico and probably ATS and probably like USB Autoscope, stuff like that, those have those types of features where, you're going to have to hit some classes or read through the help menus or watch some videos to pick up on, but you're not going to use them often, but you should know about them. At least know where to go to remember how to do them, right?
Yeah, right. Well, that's the other thing. You learn so many things the more you spend your time in the field that, well, like Sean made a joke about every time he feels like something enters in one side of the brain, something else comes out the other. And yeah, that's definitely the case. You try to avoid it, but
yeah, I just forget like birth dates. And
that's what Google Calendar is for. Then you can cheat and you don't have to remember anything. You just put reminders in there and you're done. That's what I do anyway. Got to use that technology to enable yourself to remember more things, right? I use Google Keep all the time. Like, I learned something about a car, I make a Google Keep, like a Post-it note that's digital, and then I can search my Post-it notes later and go, oh yeah, that's that thing I was trying to remember about this specific type of situation. Even like if I figure something out on a scope and I'm like, ooh, that's a really good thing, I'll like take a screenshot of how I set it up or whatever, just to remind myself, all right, just in case I forget how I did this before, I'm going to make a note about it. So in case I have to go back, I can go, oh yeah, that's how I did it. I'd like to avoid having to do that, but it's still good to have that backup just in case, because you do forget things. So you've talked about some of the different things that really make a difference as far as the composite, if you will. There's a lot of things that people ask about, what is an appropriate cost, right? What should I be spending to get a scope? I know I talk to a lot of less experienced, younger technicians who are newer to the field who want to get one in their hands, but they're concerned, they go look at a picoscope, and obviously, there's very few people who are going to debate that Pico is either option 1 or 1B or 1A or whatever you want to call it, right? There's one or two other scopes out there that people usually stack up against it and argue back and forth. It's kind of like, do you want a pepperoni pizza or a sausage pizza? It's 50-50. But at the end of the day, almost all of those that are up in that upper echelon or whatever the perceived upper echelon is, have a pretty substantial cost barrier to a lot of guys. If their shop isn't going to foot the bill for the scope, a lot of them ask, what is something they could do for an entry level, or what can they do for just getting into the scopes as a general statement. So what do you think as far as, are there options out there for people who are trying to just breach the barrier to have a scope, even if it's not their dream scope?
I got a lot of heartburn with the idea that shops aren't buying certain pieces of equipment for the shop.
We can agree on that for sure.
You can't go wrong with a U-scope. Cost, but again, it's one channel. But some of the best techs we know all have U-scopes and use them. Not just have them to say they have them.
Oh no, they have them and they use them.
It's hard not to even suggest somehow try to figure out a way to get your hands on a Pico. And I don't mean that as a Pico commercial. There's probably no way I can make that sound like not a Pico commercial.
I'm not going to argue with you on that. I tend to agree.
Even the listener, right? Like, I don't know how to make it not sound like a commercial, but I think I can back it up no matter what, that at some point, the later model Picos are so good that they do actually hide a lot of mistakes. So maybe in that case, in a way, they're bad, but
they protect you from screwing up.
They can make for a very, very lazy scope user.
Well, like I said, I've absolutely experienced that because, I spent time with the older 4000 series, and then now I have a 4425A, and holy cow, man, I have to turn off the automatic settings because I find if I don't, I feel like my skill atrophies. Like, I feel like I'm just becoming an idiot. I'm not paying attention to anything. I'm just like, derp to derp. The scope just does it for me. And I'm like, whoa, that's a dangerous game there, buddy. You can't just check out mentally. You got to pay attention here and, like, actually try to study what's going on. Like, be engaged. I think that's the peril in having any scopes that have automatic functions. I mean, so I had the handheld scope that I had before the Pico was actually a non-automotive specific scope. It was still 100 megahertz. It was still, 1 gigasample per second as total sampling. It had like 70 MPTS for memory storage. So, it was an okay scope, but it was only an 8-bit, which was kind of not so great.
Which brings up an interesting point. The lower resolution scopes are way easier to make really fast. If you start looking at scopes, you start looking at all kinds of them, you find that the 8-bit scopes, you can buy them, like you're saying, 1 gigahertz or 1 gigasample a second sample rates. You said 100 megahertz, that's bandwidth. That's kind of a specification that's insinuates the fastest signal the scope can accurately reproduce with some attenuation, but it's not overly important to us. I'm sure there's very specific situations where it is important, but as a general rule, I think it's okay.
Have you seen any automotive labeled scopes that are not 100 megahertz? Just a question I've wondered.
Yeah, most of the Picos are 20 megahertz.
Are they really?
Yeah.
I never looked at that, but I was always kind of asking myself, oh, you're right. Yeah, bandwidth right there on the Pico, 20.
I think we're far better off worrying about memory and sample rate combined along with vertical resolution. But the lower resolution scopes, the 8-bit scopes, you can buy them very inexpensively that have a lot of speed. And they're usually inexpensive. And then you go to 12-bit scopes, they're more expensive, especially if they're fast. A fast 12-bit scope is expensive. And then if you go and start looking around at 16-bit scopes, generally they're even more expensive. And for the most part, 16-bit scopes are slower. I said slower. I didn't mean slow.
Yeah.
Okay, so it's not like some big bash, because I know if anyone knows a 16-bit scope that's automotive related, they're thinking I'm bashing on the frickin' thing, and I'm not. But as a rule, a general rule, high resolution scopes are very expensive to make really fast. Okay? That's just the way it is, right? It's math.
No, it is.
When you're looking at scopes, wherever you're looking at them, this thing's too good to be true. Start peeling back the layers and looking at these specifications, and you're going to see why it's that inexpensive.
Well, and it's funny you say that, because I did that. I went down that road at one point in time when I was initially shopping for like a portable tablet one and whatever. And that's kind of what I found. So, I found the one that I used to have that I got rid of. It was a mixed sig, and it was 100 megahertz, but it was an 8-bit. It was 70 MPTS, or million points of data.
It would be 70 million sample points in the memory buffer.
It had that. You ran into the issues where there was some aliasing. I always found that there just wasn't really enough memory depth to do long captures or things of that nature. So it struggled with certain tasks, but I think it was $550. So it was, it cost very little. However, the one thing that was also that I've noticed, and I think a lot of folks don't get into, is a lot of the cheaper scopes that you go out there and buy, they come with horrible accessories, if any accessories. So like you get one and the leads are just trash. They're so bad. They got noise. They're just the quality of the signal that you pick up with them is just not good. They're often really short. They have all these limitations that really, they create headaches for you. Once you learn that and you get the cheaper scope, by the time you buy better leads, by the time you buy nice amp clamps, by the time you buy all the other transducers, you're already starting to approach the Pico territory in terms of price. So, it's one of those things where you ask yourself, is it really that much cheaper? And I found myself struggling to justify that it actually was at the end of the day, because when I got into the mix sig and I started doing a lot of scoping to get better at scoping as a whole, I had spent some time training years ago on some earlier Pico series, but it had been a long time since I used one every day. So I bought the mix sig. I started using it and retraining myself and getting better with scopes again. But when I went through the whole odyssey of building it up and getting it to where I could do most tests that I wanted to do with it, and things that I was learning in classes and whatnot, like I'm very confident I was well over the $1,000 mark by the time I bought everything. And then I started to ask myself, did I really save that much? So again, not trying to be a Pico commercial here, but it's another one of those things where, like, you're talking about the specifications, you need to drill down and ask yourself all the questions. When I look at the composite of all of these specifications, what am I really getting for the money? What am I really ending up with from a functional standpoint? Same question when you're spending the money is, what are you getting? So some scopes we see out in the market now, for instance, with TopDon, you get a scope, or like Autel, same thing, right? You buy a high-end scan tool and you get a scope, which, if you do the math on the tool, you're essentially getting the scope for free. So it's really not like you're paying a bunch of extra to get a scope. So in that regard, it's nice because you're kind of getting one more or less like it's just for free as an accessory, right? So there's less of a downside there if you're not getting the same level of performance out of it that maybe you would get something out of like, the Pico. You could swallow it, right? Because the price is not there. On the other hand, if you're going out and buying a single task tool like a scope and you're spending $500 to $1,000 and you're getting that really reduced performance, and then you buy all the other accessories, the better leads, the amp clamps, everything like that, you start to approach the cost of the Pico anyway. That's when I start to ask, are you really sure you don't just want to go full measure the first time? And it gets tougher, right? It's harder to justify not doing that.
It used to be Pico kind of had a reputation of being almost like an old supercar. If you get bored someday, see if you can find some really old, whatever that means, I guess, but try to go back into the 80s and the 90s motor trends or Car and Driver type articles about supercars. The Lamborghini Countach and the Ferrari F40s. On the racetrack, they're fun. Driving it downtown sucked.
You don't like to stick the clutch in every single time?
Well, and they made their power at high RPMs. They had the gated shifters. Like they were just, they were a pain to drive normally, day to day. If you could get out on the highway and just drop the hammer, the sound, the performance, get them out on the twisties, man, they shine. If you owned such a vehicle, you probably were not going to have your parents over for dinner and your mom wanting to run to the grocery store to get a gallon of milk and you throw her the keys to your Lamborghini because either she wouldn't be able to get out of the driveway or she would die on the way to or from, and let's face it, probably to the grocery store. They're just brutal. And now a modern supercar, whether it's a hypercar or supercar, that's not an issue. They drive normally really well. And then if you want to drop the hammer, they go. But they could be a daily driver. Maybe not in Minnesota and
with snow and whatnot.
9 months of the year. But
yeah, maybe not.
But honestly, most climates, on a nice day, hey mom, you want to take the Lamborghini? Hey mom, you want to take the Ferrari? Hey mom, you want to take the Corvette? No issues. She maybe scare the crap out of herself, but then she just lay off the throttle a little bit. She'll be fine. Picos, and this is where this sounds like a dang commercial. It's like a rehearsed stupid commercial. But the Pico, along with some other scopes, but really the Pico, I guess, is that it might be a little pricier than you would like to spend. However, it's one of those things where starting out, it's going to do everything you need to do. It's going to do the easy stuff easy. You're going to be able to set it up simply. And as your skills improve, Pico is not going to hold you back. Right. What I ran into is I bought, the first scope the shop had was a LS2000. Didn't take long to outgrow that thing. And then we had the Intero PDA 100, which was a 4-channel scope, but it was a weird layout. But at the time, it was a handheld engine analyzer. It really was. Had that. Then we got a Vitronics MTS 5100, which was a monochrome version of the MTS 5200 was Vitronics and now Bosch.
Yeah, I was going to say, wait, didn't that become a Bosch?
Yep. I had that for a while, and it was 4 channels and all, but I was running into aliasing issues like you wouldn't believe. And then I was reading an Underhood Service magazine. I'd been collecting them. I was reading Underhood Service. John Thornton was the author of or columnist, I guess, I don't know, of a series. He actually shared duties with somebody else, Diagnostic Dilemmas, and his scope screen, I didn't recognize it, so I got his email, and I emailed him about it, and it was a Tektronix handheld. So I bought one of those, and honestly, that thing took me all the way to a Pico, and I finally got a Pico, and then really didn't look back. I have other scopes for other reasons, like the U-scope, super easy to use. Yeah, I just a Snap-on Vantage Pro I like, but more for meter functions than real scope functions. Not that I don't use it as a scope, but mainly I got it for meter functions. I cannot for the life of me understand why nobody has taken that design, modernized it, and sold it to pretty much every shop in existence because I think they would buy it. If they don't buy one, they should. You know what I mean? It's like, is that good? Modernize the display a little bit, add a few more features, give it a little more speed. You know, I don't know if they'd be able to reproduce that Snap-on database for connections, which was pretty robust at the time. For the life of me, can't figure out why nobody's capitalized on that.
Well, there's missed opportunities abound when it comes to tools, right? There's always those tools that you find that you really wish someone would just make a better version of, and all day long beat that drum. And the problem you run into is so many companies now are afraid to take a leap, to take a chance on anything. They want to know we're guaranteed we're going to sell this many or whatever. And that is the harsh reality. You know, it's multiple places that I've worked. That's still the tone of the manufacturing side, is that, right? They want guaranteed sales, guaranteed orders. And boy, that is not an easy sell, unfortunately.
They wanted guaranteed sales. They just make the freaking scan tool that tells you what's wrong with the car. Done.
I thought those were like $100 on Amazon, right?
Yeah, right. About 2 a.m. you can call an 888 number and order yours.
Yeah, right.
Order one for your friend too, for just the cost of shipping and handling. But yeah, I guess that would be my pitch, is if you can somehow swing it without putting yourself in financial struggles or anything like that, it would be to go big. Best case scenario is if you have, you know, you kind of want to buy your own, I would say buy a U-scope. I'm not going to say not to get it like a Mixig or Handtech or whatever, but
right. I mean, there's other options to get into it.
If it gets you in the game, I don't think it's that bad. Just realize that, you know, you're probably spending $500 now. That's going to last you a few years, and then eventually you're probably going to be graduating to something else. And if you got somebody to kind of do the hand-me-down thing, it's great.
Years, man, that's optimistic. It took me like 8 months before I was like, I need a better scope.
Yeah, some of the other scopes, like, you know, the Autels and the Top Done, the launches, stuff like that. Like the scope hardware is, I think, fairly capable. What usually slits their throats are the user interfaces. That's stuff that can be improved. They just got to do it. But again, if it's something you can use, and like I said, it doesn't lie to you, outright lie to you, then it's not bad. You know, and again, I just don't think I can stress it enough. If you use it and you like it, who cares about all the other stuff? I mean, really.
And if you can understand it, you know, if you can get comfortable with it and really master it, anything you master is better than something you sort of understand, right? I mean, that's just reality. And that's true of anything, you know. It doesn't matter whether we're talking scopes or other stuff. Master of something is always better than dabbling. So you've talked about all the different things, you know, just some of the features that you need to be concerned about, some of the specifications, what it is that a scope can do for you, where you might go from I'm going to make a purchase. What are some considerations that you would, you know, have with respect to that? We've covered that. What are some, you have any additional thoughts you want to impart upon us just about scopes as a general statement? You know, anything that's really stands out in your mind that you'd like to share? Wisdom, just thoughts, opinions, whatever it might be.
I'm pretty sure I have zero wisdom, but I think the biggest advice I can think of is, you know, of course, something that you like, but also consider the company's support or the vendor support, and maybe even both working together. That it's nice to be able to have somebody to call and they either answer or call you right back and help you and want to help you and care about helping you. The other thing is user support. I don't know that user support can be overlooked. It shouldn't be overlooked. So a lot of these scopes we've talked about, regardless of where they rank on whatever list, a lot of them have very, very deep and passionate users that help each other out. Any of the heavy hitters I've rattled off, I mean, all of them have support groups, or I would say like on social media, a lot of support groups, professional forums. You know, you go to enough training classes, you're going to run into people that also use it. You find out they're pretty darn good with it. They give you their cell phone number and email, and you can text message them. And the next thing you know, you've got user support. And that is tremendously important. Not only helping you to learn to use it, you know, just what button makes what happen, or how to do this, how to do that. Sometimes you learn the most creative things. You know what I mean? Just somebody is bored one day and the next thing you know, they're posting up like, it's kind of a slow day and I decided to do this and look what happened. And it's just jaw dropped because like, I never thought of doing that. That's freaking genius. That's so smart.
Oh yeah. I mean, every time I go to a class, someone mentions a new way to use a scope that I'm like, oh wow, never thought of that.
Yeah. Or they found some feature.
Oh yeah. Something I didn't know that existed in the software. Yeah.
My scope does that? Really? How'd you do that? So yeah, I think that can't be overlooked. Find a vendor or the manufacturer of the scope itself that will support you and take care of you. And then the user groups, the user support, I think is super beneficial, especially as you become more and more advanced. The user support is probably more important than the manufacturer's support. Then the manufacturer support's more like when stuff breaks. The user support is what's going to make you a stronger user. I
would agree.
And I'm pretty sure every scope you could think of has a user group or more with some very strong users and get involved.
And there's general ones too, like where it's just automotive scope waveform exchange type of groups and things like that. And people will help you there even if you don't have the same scope they have. They don't care, which is awesome.
Yeah, I guess that's an important thing to bring up. It's great. You can get a waveform on your screen. You can manipulate it. You can have, compare it to other things. There's traces you're going to look at, not necessarily just voltage, but there's traces you're going to look at that you're going to be able to determine what is wrong or get a direction based off the characteristics and simple, or I don't want to say simple, but at least understanding electronics. And, we probably don't have time to get into like a lot of details, but we're probably going to have to do a part 2 because the waveform we'll pick on our voltage trace of a electric solenoid. The inductive kick is low. Okay, well, that's going to take you in a direction. You don't need a known good. Maybe if you don't know, is 60 volts good enough or should it be 80 or should it be over 100? So maybe you might need a known good. But for the most part, most of those solenoids, if you kind of know what the resistance value is, you can kind of determine about where that inductive kick should be, roughly. And it's probably, when they go bad, they don't go a little bad. They usually go a lot bad. Yeah. You're not sitting there picking hairs, usually. Now, the first one everyone looks at tomorrow is going to be marginal. I've condemned you to that.
Oh, you're in trouble now.
But there's other waveforms, specifically correlation type. So cam versus crank, to know what the cam versus crank correlation is.
Then you need a known good.
Yeah, because you can determine that the Hall effect is good, the sensor is good, whatever it is, the VRS, the Hall effect, MR sensor is good. But I don't know that they're lined up the way they should be. And the only way to know is to have a known good. And you can capture your own, but if you work on a lot of different vehicles and given a lot of time to mess around, you can maybe build up a decent database. Most of us don't live in that world. So now we have resources. IATN had a waveform library that was one time extremely robust. Diagnostic Network, I think, is building a waveform database, and then Facebook groups. The biggest one I know of offhand is the Automotive Waveform Exchange, where known good only. That's what's supposed to be. It's not supposed to be like, hey, what do you think of this waveform? What do you think of this waveform? It's supposed to be, hey, I have a whatever vehicle and collecting known good waveforms. Here's the cam versus crank, and it's searchable. And then if you can't find one, you can ask. And sometimes somebody will go, I got one of those sitting outside. I'll go grab it. Very, very powerful. Very powerful.
And people are pretty motivated to help each other out, because the reality is if you help each other out in a jam, I think that's the tone of what we need to push forward more in the field as a whole, is that mentality of help each other out, right? That's how you make things better, is by everybody trying to help each other out and make things better, right? Collectively, we will solve more problems. Simple.
Yeah, I think hopefully when it becomes mutually beneficial. Hopefully it doesn't go into that like Pareto distribution where you have the few doing all the legwork and the many reaping the rewards. Hopefully everyone tries to pitch in a little bit, one way or another.
You would hope. Generally speaking, I think that's fair. Now, I had one question for you, and this was actually spawning off a discussion I had with somebody else about a specific scope situation. So maybe this is better reserved for the next scope discussion. But I had a friend who asked me about something on a vehicle. He was trying to look at a pressure regulation solenoid of some type. He had scoured everywhere he could find to find a known good, and he couldn't find anything. And he wanted to see if he could think of a way to approximate what maybe it should look like without having a known good. And I said to him, well, if this is a pressure regulation solenoid, are there any other vehicles out there in your lot that have a solenoid on them that acts in a similar fashion, is used for a similar function? I said, it isn't going to be a verbatim, yes, it's going to be exactly like yours in terms of how it operates, but there's a decent chance that one of these other style solenoids that's used in a similar function will have a similar waveform. And like you said, a lot of the time things will fail like bad, right? They're real bad. They're not just a little bad. So I had suggested to him maybe trying that. So, when you're mining the known goods, have you found that to be helpful, where maybe you draw an analogy or you can maybe make a connection to something that might be a similar system to try and understand what your possibilities might be if you can't get a known good?
I mean, you'd have to know like the real characteristics of it. So if the solenoid you're talking about, for the most part, if it's the same control strategy and the same, we'll just say impedance or resistance, most likely it's going to behave very similarly to the other one. Where it run into problems is this is saturated switch versus something that's not, peak hold. Now all of a sudden it's like, no, they're really not going to look alike. And, I guess we could really start picking apart that statement by saying for the most part, peak holds have much lower resistance than a saturated switch. But, off the cuff, I'm just thinking like control strategies, if they're quite a bit different, they're not going to look the same. And then the actual design, if you will, and I would think impedance is the big one, is different. You can't do it. But if they're relatively the same, kind of thinking like a shift solenoid versus a fuel injector, if it just so happens that the impedance or the resistance is virtually the same and they're both pulse width modulated or both saturated switch, they're probably going to be remarkably the same. I suppose it's possible, very specific situations where one system has clipped inductive kicks and the other one doesn't. But still, you might be able to see that, and now you're talking a little more about a seasoned user being able to look at an inductive kick and go like, well, that's being clipped. This one isn't, but everything else looks good. I can move on. I'm going in a different direction. And like I guess a good way to end and set up maybe a part 2 down the road is another piece of advice. As a general rule, I think scope usage, people are thinking about picking the fly excrement out of the pepper. Like you're going to be analyzing these little tiny anomalies to figure out what's wrong. And I got to level with you. The vast majority of the time, vast majority of the time when you're using a lab scope to test a circuit, when something's bad, it's obviously bad. Especially if you have something kind of known good, right? Like either you've seen it before or you have a system, let's pick on like ignition coils. Usually you have more than one ignition coil on a car.
Yeah.
At least modern cars.
Yeah, generally speaking, yeah.
So you kind of have one to look at and compare. And that happens a lot. Like there's a lot of things on the car that kind of have other components that are the same. And then you can kind of look at one and compare it and go like, okay, well, pretty much the same. Generally, things when they're bad, they're really bad. It's not subtle. Again, now I've condemned everybody. Tomorrow, everything you're going to look at is going to be very subtle, very marginal.
Everything's a plausibility fault tomorrow, right?
Yep. I apologize for that sentence, but that's, for the most part, they're obvious bad. It's just, you're not sitting there picking out these little details going like, oh yeah, I mean, this has this little bump here and this one doesn't. It's probably not the problem. You're going to go down a rabbit hole. You're looking for really macro type failures. Don't worry about the micro stuff until all the macro stuff is eliminated. Now you can start to worry about the micros. But if you're diving right into those micro type issues, you're probably setting yourself for a very bad experience and you'll never want to use a scope again.
Yeah. Over-romancing the scope experience, kind of like what you talked about with Paul.
Yeah. Going crazy. Well, thank you very, very much for joining me tonight.
Definitely enjoyed it.
Hopefully there's some stuff you guys can take away from this. And if you have questions, we addressed the ones that were sent in and then tried to, project out from there. But if you have other questions about scopes, using a scope, please do not hesitate to reach out to me via social media. Also email me at mattfonslopodcast@gmail.com. And I hope you enjoyed this. Thank you again, Haakan. Thank you, NAPA, for sponsoring. Thank you so much to Aftermarket Radio Network and Carm for hosting this, making this all possible. And until next time, take care.
You've been listening to Matt Fonslow, diagnosing the aftermarket A to Z on the Aftermarket Radio Network. Follow Matt on your favorite listening app. He's very interested in what you have to say. Let him know what you'd like him to cover and come on the show. Matt is all for advancing the aftermarket. Find Matt Fonslow on social media and connect or on aftermarketradionetwork.com.